Hello, we are the group 3, formed by Natalia Silva, Arnau Suero and myself, Guillermo Torres. Today we're going to try to solve the project 1 of CSD about logic gates and Boolean algebra. In order to learn this subject, we're going to try to solve the truth table of the circuit 1C, following 3 different methods. The first method is going to be using the tool Proteus, the second method is using the Wolfram alpha, and the third method is applying Boolean algebra.
Well, I will talk about the first method. Is using software. We will use the software called Proteus to find the truth table. The way we are going to find the truth table is implementing this circuit that has already been implemented in Atenea, well, in Dixis, and getting this project. Implementing this system, so we have the outputs like buttons, so we pass every button and we click every combination with these 4 bits, so we will have 16 combinations, and we will have every combination will have an output. So with these outputs and combination we can find easily the truth table. Once we have find the truth table, we have to do one more thing, is to designing a simplified circuit of this one. So what we have to do in this project is, with the truth table, we have the min terms and max terms. This is the expression, mathematical expression. So having these min terms and max terms, we can do this as a sum of products, or we could do a product of sums, every sum. In this blackboard we have an example of a sum of products. So we have to get every max term, every zero, that's true, I must say this, every output have ones or zeros. So every zero is a max term. We will have this one, and 1, 2, 3, 4, 7, 8, 9. So getting this, we can design the inputs that will be those ones, and summing every of these products. So this is a sum of products, and this will be a simplified expression of this circuit. And well, this is all we have to do in the first method of Proteus.
In the second method is the Wolfram alpha. We separate the circuit in 2 small circuits, G and W. This is a mathematical expression where the AND gate is a product and OR is a sum. The C is the product of G and W. And the web of Wolfram, we put this input interpretation in language of Wolfram. In mini-log program, we put the truth table of Wolfram and we obtain a simple equation and truth table. This explanation is a sum of product, the circuit C.
Now we're going to try to solve the circuit 1C truth table following the method 3, Boolean algebra. To solve this circuit, we got to split it, as Natalia did before, into 2 smaller subcircuits, the subcircuit G and the subcircuit W. As we see here, we're going to follow Boolean's algebra, and here we have the 3 inputs. As we can see in any of those, we have 3 inputs, but 1 is missing. In order to find the max term or min term of the circuit, we will have to implement the missing variable. In this case, the D1 is missing, so we're going to implement it as a NOT and as well as a normal input. Here we see that the NOTs, the NOT variables, as we see here, D1 and A are 1s. So here in binary, we see the number 10. As we see here, we have taken the master number 10. D1, 1, 0, 1, 0, number 10. And here we see 0, 0, 1, 0, that's the master number 2. Following this kind of operations, we can complete and conclude that the G output is a product of sums of these variables, and then we see that the W input is something more complicated. because we have combined product of sums and sum of products in the same operation. So now, in order to simplify this and solve it, we're gonna do a smaller truth table of the W subcircuit. To do this, we're gonna do again the Boole's algebra for this simplified subcircuit, and we're gonna obtain the sum of min terms of the W. As we see here is a sum of three different inputs, and we have obtained that the min terms are the 0, 2, 3, 5, 6, or 7. That is equal to the max terms, the product of max terms 1 and 4. Now, once we have all this, we're gonna combine it. This simplified equation, as we see here, that's a product of sums of the W. We're gonna combine it with the G, and we're gonna obtain the final output of the circuit, the C. As we see here, the final output of the C is a product of this term, the 1, 2, 3, 4, 7, 8, 9, 10, 12, or a sum of 0, 5, 6, 11, 13, 14, and 15.